Chapter 5 Examples for Business Finance. In Chapter 5, we continue looking at time value of money problems. We, instead of lump sum figures like we looked at in Chapter 4, we will be looking at annuities, which, if you remember from the chapter lecture or from the chapter reading, annuities are regular payments that occur at regular intervals, usually once yearly or once monthly for a finite amount of time. So we'll be looking at things with regular cash flows or more than one cash flow rather than the lump sum items that we looked at in Chapter 4. As always, there are 3 different ways to do these calculations, 4, but the textbook goes over 3. We can do the calculations in Excel using Excel formula functions. We can do the calculations using the math equations. We can do the calculations in a financial or scientific calculator, and those instructions are listed on My.Wartburg and in your textbook. And we can use a time value of money factor table that we've practiced that a little bit personally in class. So we're going to, with these examples, we're going to look at the equations and the Excel functions. So with this first one, we are looking at calculating the present value of cash flows at 3 different percentage rates. When you have different cash flows in every year, you need to calculate each one of the cash flows individually because they each have a different time of collecting interest. So when we're looking at the present value factor, or we're wanting to know the present value of these amounts. So the present value then equation, remember, is the future value divided by 1 plus the rate to time. So we need to do that for each one of these cash flows if we're going to do a mathematical equation. So we have, let me make that font just a little bit bigger so you can read it. So we're going to do each cash flow individually. And we want to make sure we put parentheses out around them so we do order of operations. So year 1, the future value divided by 1 plus the rate. We're going to do the equation for 10%, and we'll do the Excel formulas for the other 3. 2, 1 plus year 2, 430 divided by 1 plus our rate of 10%, then to the power of 2 for year 2, plus year 3 divided by 1 plus the rate to the power of 3 plus year 4. Yep, year 4 divided by 1 plus the rate to the power of 4. Now this is the present value calculation. That the future value is a different formula. Okay, so we have that amount there. We can also use in Excel the net present value function. So the net present value is when we're wanting multiple cash flows at a time that are different cash flows within different years. So remember yesterday and then later on in these examples, we've been using the present value formula function, but we're going to be using the net present value for this one. So equals, the net present value function is NPV. Then your parentheses, we do rate, and then we select the value. So first we want the 10% rate, and then a comma, and then we're going to select all four of the values. You can see that we get the same exact result from the Excel formula that we do in doing the long formula. So we can do the net present value calculation for each one of the rates. And we can see that as the interest rate increases, the present value goes down. And that is because these are the future value of what we would earn if we put away the present value at a specific interest. And the more interest you earn, the smaller your present value. The more interest you're going to earn in the future, create that future value, the smaller your present value. In this next example, we're going to look and try to decide which one of these has the higher present value. And first, we're going to look at what is 6%, compare the two investments at 6% discount rate, and we're going to compare them again at a 22% discount rate. So the first one is that we're offered $3,100 for 9 years, and the second one is $4,800 for 5 years. And we want to know which one of them has the highest present value. For this one, we can do the calculations by using the formula or looking at the present value or time value of money tables. We want the present value, so you need to make sure you're checking the right table. So first, this one's future value. This one's also future value. What we want is the present value of an annuity. So this one is the present value of $1, and we want the present value of an annuity. So remember, the annuity is when we're getting regular payments. So we're getting a yearly payment, so we want the annuity. First, we need the 6% factor for 9 years. So we see the 6% factor here for 9 years is 6.8017. So we're going to put that in for our factor is 6.817. And then we need the factor at 6% for 5 years. So 6% for 5 periods. That factor is 4.2124. 4.2124. So we take our cash flow or our payment times the factor, and that gives us the present value of that amount. 4,800 times the factor, that is the present value of the amount. This is for 6% for 9 years, and this is at 6% for 5 years. We can also do the present value calculation formula in Excel. Remember, we have to put a negative to get Excel to do the math correctly. So we pick rate. Our rate is 6%, the number of periods, which is 9, and then the payment, which is $3,100. You can see that we come out with the same exact number. We can also use the present value calculation, which remember is the future value. So the 3,100 divided by 1 plus the rate, power of the number of years, or the number of periods. So we can calculate the present value with our rate, time periods, 5 years, and 4,800. You can see that we get very similar results to what we got from the factor table. Any difference, I mean, 25 cents here, that's just a matter of rounding, or just shy of $1 on this one. And you can see if we extended it out, it would actually only be about 17 cents. So then our value at 22%, we're going to have the present value, the rate, time periods, and the payment, and then present value of the rate, time period, and payments. So we can see that we get more money if at 6%, the 3,100 for 9 years has a higher present value, where at 22%, the 4,800 at 5 years has a higher present value. In this next example, we're looking at the future value with multiple cash flows. So we're trying to calculate what are the multiple cash flows. For this, we have to do the formula. So the future value calculation is where we do each year separately. So remember, it's present value times 1 plus the rate, the power of the number of years that it's earning interest. So it's a flip of the present value formula that we did in number 1. So we do each cash flow individually. So 1 times 1 plus the rate to the power of 3 plus your 2 times 1 plus the rate to the power of 2, because that's how many years it's going to earn interest, plus your 3 times 1 plus the rate to the power of 1. And then in year 4, that money has just been deposited, so it won't earn any interest. So remember, we're looking at present value now instead of future value of these funds. We can, in Excel, if we lock our cash flows, we can copy that formula instead of retyping it, and it will give us the future value of those amounts. Example number 4. So we have an investment that offers $6,125 per year for 15 years. The first payment occurs a year from now, so at the end of the period, which makes it an ordinary annuity. If the required rate of return is 8%, what is the present value of the cash flows? So we have the present value. If it's a 15-year of payments, so we do our present value. We want the rate is always 8%, but the number of periods is going to change. So 15 years for the first calculation and 6,125 for the payments. In the second equation, we're doing the same numbers for the rate and the payment, but we're going to increase that for 40 years. And then for 75 years, and then in perpetuity. So if you remember, perpetuity is regular payments forever. So they don't have an end date like an annuity does. An annuity has an end date. Perpetuity is regular payments forever. So perpetuity calculation is payment divided by the interest rate or the express interest rate. So we have the payment of 6,125 divided by the 8% interest. So the present value of the perpetuity is $76,562.50. Then the question asks, what's the difference between the perpetuity and the annuity at 75 years? Well, it's $238.36. So we can say, how long can we go in? Why are they so close together? Is 75 years really forever? So how long? Remember, the further out that we get, the less impact the present value change has. From 15 years to 40 years, we have a pretty significant change. Then you can see from 40 years to 25 years, we're only looking at just over a $3,000 change. Now, if you remember in class, we played around with this. At what point does the perpetuity equal the present value of something else? And I think we had to go to 160 years in order to get that close. So 160 years of payment, that comes out to 34 cents difference between 160 years of payments and the perpetuity.